Okay, Pute. Again, good afternoon, everyone. Now we are going to start today's lessons. Actually, we were discussing about quick recap series, but now we can start the today's lessons. After doing some theory part, then you will be given a 5 questions series. Then you have to give the answers. Okay. Okay. Okay, Buddha. Everyone, please look at me. Look at board. Actually, we were discussing about linear motion, and we were discussing about how to represent a motion or how to represent a linear motion using a graphical method. That means, as you know, now we are going to discuss about ST curves, VT curves, and AT curves is that is not in the syllabus, but we will discuss about that also. Okay. Okay, now we are discussing about motion graph. But before discussing about motion graphs, we have to have very good understanding about graphs. Okay, otherwise we cannot understand about motion graphs. Therefore, now I'm going to give some understanding about graph, how to draw a graph, and how to understand, how to read a graph. Okay, because in physics, you will be given various graphs with various variables. Therefore, we cannot learn each and every graph separately. Okay. Therefore, now we are going to discuss about graph. Then we can learn about motion graph. Okay. Actually, this is a very descriptive lessons of graph. Descriptive lessons means I will be discuss about graph in descriptive way, because this is very critical lesson, because in physics there will be lot of graphs with lot of variables. Therefore, you have to have very good understanding how to read such graphs or how to take some required information from a graph. Those kind of things you have to have very good understanding. Okay. Therefore, today I'm going to discuss about graph. Okay. Actually, we have started to discuss about graph, but now I'm going to discuss from the beginning. From the beginning means because there are no new students there. Therefore, I will be discuss that thing from the beginning. Okay. Okay. Look at this. Graph. So what is a graph? Quickly. What is a graph? According to my previous definition, that is my own definition. Okay. That is my own definition. So what is a graph? What is a graph? Yes. It is actually
drawing on Cartesian plane.
Yes, very good, Puta. Actually, it is a drawing. It is a drawing. We can simply define it as a drawing. Drawing on a Cartesian plane. On the Cartesian plane, no? Normally, we will draw a graph on a Cartesian plane, no, Puta. Therefore, we can simply, not a definition, but we can simply define a graph as a drawing on a Cartesian plane. So if it is a drawing, we have to decide two things before we start to draw a graph. What are those two things? Location and shape. No, if you have actually, if graph is a drawing on a Cartesian plane, look at this one. Okay, if graph is a drawing on a Cartesian plane, then we should know two things to draw a graph. The first thing is location. Location, no? Actually, in a class on a Cartesian plane, there are 4 chambers, no? 4 chambers. So 4 quadrants. Normally we call this as quadrant. Okay, this is first quadrant. Quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. So the first thing you have to decide, you have to determine the location. The location means where are you going to draw this graph? Whether it is on the first quadrant or second quadrant, third quadrant or fourth quadrant. That thing you have to decide first. Okay. Once you decide that thing, once you decide the location, then you have to decide the starting point. So it's not the starting point. You have to decide the shape and the range. Shape and the range. Okay? If you know the shape and the range and the location, then you will have a graph. Okay. The first thing you have to decide the location, then shape and the range. Shape and the range. Okay. Okay. Then now you have the argument. No, now you have the argument. What is the argument? If you want to draw a graph, we have to have two things. What are those? The location and the shape and the range. Shape and the range. So how to decide a location? Location means the quadrant. Quadrant. So how to decide the quadrant or location? How to decide that thing?
By the gradient of the graph.
Sorry? Sorry, Bute? I didn't hear you.
By the gradient of the graph.
Gradient of the graph. Is that the thing who decide the location? Location. I'm discussing about location. Whether it is on the first quadrant or second quadrant, third quadrant or fourth quadrant. How to decide the location?
Positive or negative signs of y-axis.
Sorry, Pate?
Positive or negative signs of y-axis.
Not only y, but also x. Okay? Therefore, look at this. If we want to draw a graph on first quadrant, that means both x and y should be positive. Both x and y should be positive. If we want to draw a graph in second quadrant, y is positive, but x is negative. X is negative. If we want to draw a graph in third quadrant, what will happen? Y is negative and x is negative. That means if x and y are both are negative, the graph should be drawn on the third quadrant. If x is positive and y is negative, then where should you draw the graph? If x is positive, y is negative, where should you draw the graph? Graph. X is positive, y is negative. Then the graph should be drawn on the fourth quadrant. So what is the factor who decides the location of the graph? So what is the factor? The positive or negativeness of x and y coordinates. X and y coordinates. If x and y coordinates both are positive, the location of the graph is the first quadrant. If x and y coordinates, if x coordinate is negative and y coordinates are positive, the location will be the second quadrant. If both are negative, the location will be third quadrant. If x is positive, y is negative, the location is fourth quadrant. Okay. අපි මේක ලියාගත්තද පුතේ? හ්ම්? ඕ කට්ටිය.
Sir, we have written after the shape of the
Okay. We have write the location, no? We have write this. Have you written this down? Have we done this one? I have to check that one.
Sir, we have written it but not drawn this diagram.
We didn't write draw this dragon. We did not draw this dragon.
No, sir.
Okay. Then okay. We can write this one as a note. Note, okay. Have you write the topic, the shape of the graph?
Yes.
We have write the topic, no? But we did not write anything under another topic, no?
We have drawn another diagram, sir.
How to decide the shape of the graph? That is the topic, and we did not write anything another topic, no?
No, sir, we have write that.
Okay. Okay. I will give this one as a special note. Okay. Okay. So what is the factor who decide the location of the graph? The positive or negativeness of x and y. Positive or negativeness of x and y. Okay. So that is the first one. That is the first one. Then shape. How to decide the shape? Once you decide the location, then you have to decide the shape. Once you decide the location, then you have to decide the shape, Puta. So, how to decide the shape of the graph? Okay, sorry, I have a call. Okay, tell me. Then, how to decide the shape of the graph? I think we have done up to that, no? How to decide the shape of the graph? Once you decide the location, now location is decided by the positive or negativeness of x and y. Okay. Actually, we have discussed if it is a motion graph. You know about motion graph. The x-axis is always time. Therefore, time cannot be negative. Therefore, there is no any negative side of x. Therefore, you have to decide only first quadrant and the fourth quadrant only. That means the positive or negativeness of y only. If it is a motion graph, the x-axis is always time. It is always time. Okay, Putir. Thank you. Okay, always time. If it is a motion graph, x-axis is always time, Puta. Therefore, there is no negative side of x-axis because time cannot be negative. Therefore, there is no any negative side of x-axis, Puta. Okay. So, if it is a motion graph, then the location, if you want to decide the location, then there are only two options. What are those? Whether it is this side or this side, this one or this one. Therefore, if it is a motion graph, the location depends on the positive or negativeness of y-axis. No, if y is positive, we can draw the graph on this location. If y is negative, we can draw the graph on this location. Therefore, if it is a motion graph, then actually there are only two options. It is very easy. So, there's a reason why time is here. There's a reason. Now we are going to discuss that thing also. But you know that graph, no? Because in all others you have done motion graphs. Therefore, that's why I give that information. If it is a motion graph, then there are only two sides to decide. Okay. Hurry. That also done, no? Then, how to decide the shape? Then shape. Now you have decided the location. After that, you have to decide the shape. So, how to decide the shape? Shape is decided by the gradient of the graph, the gradient. That is the final part we have discussed. We discussed in our previous class. This gradient. Actually, if we may discuss about the shapes, actually there are only few shapes: curve shapes and straight lines. Actually, there are only these kind of shapes. Okay. Whether the graph is like this, then this part is like this shape. This part is same equal to this shape. Therefore, any graph, if we consider any kind of graph, there are only 8 shapes. 8 shapes. This can be, we can draw these shapes in this quadrant also, this quadrant or this quadrant or this quadrant. We can draw this graph. So if it is a motion graph, then the same pattern can be repeated. The same pattern can be repeated in the fourth quadrant. Therefore, we will have only 16 number of shapes. Okay, only 16 number of shapes, but those are repeated again. Okay. The shape is decided by the gradient of the graph. So what is the gradient? What is the gradient of the graph? What is the gradient of the graph? What is the gradient of the graph, Puta? I think you know this thing because you have done this thing in your all syllabus. So what is a gradient? What is the gradient of a graph? What is the gradient? Can anyone tell me? What is the gradient of graph? Can anyone tell me? Gradient? What is a gradient? Okay. I think you know this thing, but what is the gradient of the graph? මතක නැද්ද gradient කියන්නේ මොකද්ද කියලා? Gradient එක ඈ අත උස්සලා දෝලවල වලින් අත උස්සලා දාවේ කට්ටියව. Okay. Okay. There are correct answers. X or Y, no? Plus or Y or X. Okay. Sorry. So gradient of the graph. Yeah. No. The previous definitions are correct. We cannot say directly proportionality. Directly proportionality means, yeah, that's about directly proportionality. Yeah, that can also be correct. Okay, when I see the definition, I call the definition that okay. Do you know the meaning of that one? The line directly proportional to x and y axis. That is a very good definition. Very different definition. Very good one. Do you know that thing? Can you explain that thing? Can you explain that thing? Irushigane. That is a very good definition, Buddha, but very different definition, but correct definition. Can you explain that thing? Okay. Okay, there's another explanation. There's another explanation about the gradient. That is very different definition, but it is 100% correct. What is the definition? Line directly proportional to x and y axis. Line directly proportional to x and y axis. Okay, this is a question for everyone. This is a homework. This is a homework. Can anyone explain that thing? Can anyone explain that thing? Okay, line directly proportional to x and y axis. Line directly proportional to x and y axis. That is not the definition, but it is equal to m or gradient. Okay, so my question is, explain about that definition. Okay. හැමෝම ගත්තා නේද මේ definition හැමෝම ලියාගත්තද? This is very that is very attractive definition. හොඳ definition එකක් ටක් ගාලා වගේ ඔළුවෙන් හිතන්න ඕන definition එකක් හොඳ. මොකද නිකන් උඩින් බලලා කියන්න ඕන definition එකක් නෙවෙයි. හැමෝම හොඳට හිතලා උත්තරයක් දෙන්න ඕන definition එකක්. Okay? No. No. You have defined a gradient, no? Yeah, that's correct. My question is, explain the previous answer. Okay, Yurushika, you gave an answer. The gradient is the line directly proportional to x and y axis. Okay, everyone, please explain that thing as a homework. homework ඉදිරියේ එක හිතලා කරලා මට answer එක එවන්න. හරිද? හැබැයි ඉතින් එහෙම එකක්වත් ඔයගොල්ලෝ කරේ නැහැ හොඳේ. මම අර නිව්ටන්ස් ලෝස් මේ තුනම එකයි කියලා පෙන්නන්න කිව්වා නේද? කොහේ එක? නිව්ටන්ස්ලගේ මේ නිව්ටන්ගේ ලෝස් තුන තියෙනවානේ. ඒ ලෝස් තුනම එකයි. මම ඒකත් පෙන්නන්න කිව්වා. Explain. Explain in a rough sheet, okay? It cannot be done by wording. It cannot be done. You have to write some equation. After that, you can show the gradient is equal to your definition. Okay. I cannot say otherwise. It will be the answer. Okay. Okay. Look at everyone. Please look at the board. Everyone, please look at the board. So the graph. The gradient of a graph. The gradient of a graph decides the shape. So if we can, sorry. You have touched the answer, but I wanted to have that answer in a separate rough sheet with calculations. Okay, with some proof in. Okay, that with you have to prove that thing. Okay. Okay. Look at the board again. දැන් කියන්න එපා දැන් කියන්න එපා දැන් එතකොට මේ මට කරන්න වෙන්නේ නැහැ ක්ලාස් එක. Okay. Please send your answers as a separate message. Okay. Do some rough calculations, or if you can explain that thing by words or sentence, then that also okay. But I think you cannot do it by wordings only. So if you can explain or if you can prove that thing, please take a photograph and send that to me. Okay. That's depend on you. You have to think. How should you prove? You have to think. Okay. Okay. හිතලා එවන්න. Okay. Let's go to the lesson again. Okay. So if we take a graph, Puta, so there are only 8 number of shapes. Okay, so if I repeat that thing in the fourth quadrant also, then there will be 16 number of shapes, but mainly there are only those shapes. Okay, so the shape of a graph, the shape of a graph depends on the gradient. Depends on the gradient. So now we are going to define the gradient of a graph. The gradient of a graph. So how to define a gradient? How to define a gradient? Please listen very carefully. Suppose there's a graph here. There's a graph here. Actually, we have to define a gradient at a particular point because point to point gradient may be changed, may be varied. Okay. Gradient may be a constant, but it may be changed or varied. Okay. So normally gradients is defined for a particular point. Okay. Suppose P is the point. P is the point. Now I'm going to define the gradient of this graph at point P. The gradient of the graph at point P. So if you want to define a gradient of the graph point P, the first thing you have to do, you have to draw a tangent. You have to draw a tangent for this curve at point P. Okay, you have to draw a tangent. So this is the tangent at point P. Okay. So once you draw the tangent, you have to extend that tangent up to x-axis. Okay. So if you extend the tangent up to x-axis, then measure this angle. This angle. What is that one? The angle between the tangent and the positive side of the x-axis. The angle between the tangent and the positive side of the x-axis. So suppose there is this is the intersection point. No? This is the intersection point of this tangent and the positive side. So tangent and the x-axis. Suppose this is a. So this is the intersection point. Intersection point of tangent and the x-axis. Okay. So how to decide the positive side? How to decide the positive side of the x-axis? If you want to decide the positive side of the x-axis, the first thing you have to determine this intersection point. If you know this intersection point, then the right-hand side is the positive side because every time positive side is into the right-hand side. Therefore, if we extend the tangent up to the x-axis, the right-hand side is the positive side of the x-axis. The left-hand side is the negative side. Okay. So this angle is defined the angle between the tangent and the positive side of the x-axis. Positive side of the x-axis. The gradient of the graph at point P, the gradient of the graph at point P is defined as the tan value of that angle. The tan value of that angle. Okay. Therefore, the gradient of the graph is defined as the tan value of the angle between the tangent and the positive side of the x-axis. Did you understand that one? There is only a definition. Theorem. Oh, theory ille. Okay, please give your responses. Others? Okay. Again, I will tell you. Everyone look at the board. Gradient of the graph means the tan value of the angle between the tangent and the positive side of the x-axis. So if you want to find a gradient, if you want to find a gradient, the first thing you have to do is you have to draw a tangent at the particular point. You have to draw a tangent. Once you draw the tangent, then take this angle and take the tan value. That is the definition. That is the definition. Okay. There another. Steve, Yanusha.
Yes, sir.
Okay. Write a topic. Oh, sorry, not a topic. For this angle, Puta, this angle, theta. If theta is 30, you have to take tan 30. Tan 30 means √3. If theta is 40, you have to take tan 40. You don't want to write a triangle. You don't want to draw a triangle. Okay. Actually, you have a logbook, no? Logbook. Oh, now we have calculators. So we can measure the thing. Okay. Okay. But you don't want to worry about that because you will be not asked about that. Okay. Logbook on. No, Puta. You just measure the angle. Once you measure the angle, you know the tan values, no? Because tan values for every angle has been calculated. It's already calculated, no? No. If you want to measure the value of tan 40, can't you measure that one using logbooks? Can't you measure that one? Do you want any triangle? Do you want any right angle triangle to measure tan 40? No, you don't want to. You don't want a right angle triangle. No? If you know the angle, suppose the angle is 55. Suppose the angle is 55. If the angle is 55 degree, can't you measure the tan value? Can't you measure the tan value? Using logbooks, can't you measure? Because in logbooks, there's a column, tan column. No, you can measure the tan value of any angle using logbooks if you want. Therefore, you no need to measure. This is definition, Puta. This is definition. Okay, this is a definition. I will explain that thing. Okay, I will explain that thing. What is the mathematical part of gradient? That is another lesson. Okay, I will explain that thing in that lesson. What is the mathematical part of that lesson? But until then, this is the definition of tan value with the definition of gradient. Okay, this is definition. Okay, this definition based on mathematical part. This is a very complicated mathematical part for bio students, but I will explain that thing very simple method. But you want to know the definition of a gradient. Otherwise, if you are a mathematical student, then you will learn that thing in differentiation. Okay, what is the mathematical thing behind the gradient? Okay, So we don't want to define the mathematical thing, or we don't want to calculate the mathematical part of the gradient, because there is no needed. No needed, because it is not in the physics syllabus, but that is in the math syllabus. But I will learn, I will teach you the mathematical aspect of gradient, okay? In very simple words, okay? Okay. Right under the topic, no topic. Write in new paragraph. අලුතෙන් ආපු කට්ටිය මේ වෙනම rough sheet එක ලියාගෙන rough sheet එක මොකද ලියාගෙන ඊට පස්සේ note එක complete කරගන්න. Okay, we have done 2 classes up to now, so you have to complete those notes after this class. Okay, හරි. Okay, if we consider the above shapes, if we consider about shapes, there are only 8 types. There are only 8 types. Types. We can draw those shapes. In other quadrants too. We can draw those shapes in other quadrants too. In another paragraph, the shape of a graph
Excuse me, sir.
yes,
I had a small connection problem. What was the sentence you said before? Before we can draw those shapes in other quadrants, the one before that. If we
Sorry, Bhute.
consider
What is the last sentence you wrote?
We can draw those shapes in other quadrants too. The one that the sentence that you told before, that's what
Then write that one in another paragraph. The shape of a graph, the shape of a graph, the shape of a graph is determined by the gradient. The gradient. Okay. You you want the first sentence?
Yes, yeah.
Sorry. First sentence.
Sorry.
There.
So you started with if we consider.
Yeah, if we consider the shapes of the graph, there are only 8 types. If we consider the shapes of the graph, there are only 8 types. ඒක නේද මං කිව්වේ? Is it same with my previous sentence?
Yes, sir.
Okay.
Thank you, sir.
Okay. They write a topic. Gradient of a graph. All right. Okay. Everyone, I need your responses. I need your comments. Do you understand this one? About gradient? About the definition of the gradient? Do you understand about the definition of the gradient? Everyone, I need your responses. Everyone, I need your responses. Where's the others?
Yes, sir.
Thank you. The gradient means? Yeah, thank you. The gradient means the tan value of the angle between the tangent and the positive side of the x-axis. Okay. Once you draw this, once you write the topic, please draw this graph only. Okay. Right under the graph, okay? Have you finished drawing? Have you finished drawing? No? Okay. Then right under this graph, right under the graph, the gradient of a graph, the gradient of a graph can be varied from point to point, from point to point. Therefore, the gradient is defined. The gradient is defined for a particular point. For a particular point on the graph. Okay, I will repeat from the beginning. The gradient of a graph can be varied from point to point. Can be varied from point to point. Therefore, the gradient is defined for a particular point on the graph. For a particular point on the graph. Okay. Right under that. The gradient is defined as the tan value as a tan value of the angle, tan value of the angle, as a tan value of the angle between the tangent, the tangent, the tangent tangent at a particular point, at a particular point, the tangent at a particular point, and the positive side of x-axis, the positive side of x-axis. Okay, write these two things. Quickly. හරි. ලියාගත්තද? පොතේ. පළවෙනි දේ තමයි කියන්න තියෙන්නේ අපි දැන් ඩේලි මේ වගේ ප්‍රෝග්‍රෑම් එකක් කරනවා. ඒ කියන්නේ ක්වික් රීකැප් එකක්. ඒකට මම අර hard rules නෑ. මෙතන කියන hard rules නෑ. hard rules තියෙනවා එක්සෑම් එකක් නම් යුනිට් එක්සෑම් එකක් නම් hard rules තියෙනවා. හරිද? මම එතකොට ඒකේ අපි ටයිමින් කරලානේ අපි වෙනදාට කරන්නේ. හරිද? කරේ එහෙමනේ. මේක එහෙම නෑ. ඒ නිසා ඕගොල්ලන්ට ඕගොල්ලන්ගේ ටයිම් එක ගන්න පුළුවන්. ඒක කිසි ප්‍රශ්නයක් නෑ. නමුත් මම රෙකමන්ඩ් කරන්නේ 10 minutes. මම රෙකමන්ඩ් කරන්නේ 10 minutes. මොකද 10 minutes ඇතුළත ඕගොල්ලෝ මේක හුරු වෙන්න ඕනේ. හරිද? මගේ මේකේ හැබැයි මම මේකේ තනිකර මම මේ ක්වික් රීකැප් එකක් කරන්න පුතේ මේ ඔයාලගේ අර පරණ ලෙසන්ස් ටික ඇස්සලා කොළුවට ගන්න. ඒක තමයි මගේ මේ අර ඒකේ තියෙන මේන් ගෝල් එක. ඒක නිසා මට ඒකදී ඔයගොල්ලෝ ඒක කරන්නේ කොහොමද කියන එක මම මේ රෙස්පෙක්ට් එක මම ගණන් ගන්නෑ. හැබැයි මතක් කරගන්න එක කරන්න ඕනේ. හරිද? ඒක මට අවශ්‍යයි. ඒ නිසා මේක අර සීරියස්ලි හිතන්න එපා. සීරියස්ලි හිතන්න එපා කියලා කියන්නේ ආයි ලොකුට ආයි ඕවර් ස්ට්‍රෙස් එකක් කරගන්න එපා කියලා මම කියන්නේ. හැබැයි you have to face that one. You have to face that one and you have to identify your weak point. You have to identify your weak points, and if there is any mistakes, you have to identify them, and then you have to check the answers, and you have to go through your lessons again. Then you can find the answers. Likewise, you have to do your own recap. Okay, so that is the main aim or the main goal of this quick recap series. Okay. Okay. Then shall we go to the next lesson? Okay. Up to now, we have discussed about the location, how to decide the location of the graph, then we have discussed how to determine the shape of a graph. Okay, when we are drawing a graph, we have to determine two things. What are those two things? Location and the shape. Okay, then now we are going to discuss about some special cases of gradient. Special cases of gradient. Okay, now actually this is the most important part in the graph lesson. Okay, in the graph lesson, this is the most important part. So please listen me very carefully. Please listen me very carefully. If you have any connection problems, please go through the recordings again, because this is very critical part, very critical lesson now. Listen. Okay. Okay. What is that? This is about gradient. This is about gradient. So now we are going to study about gradient very deeply. Very deeply. We are going to discuss about the gradient, each and every small points of the gradient. Okay. Then write a subtopic on not a subtopic. It is a main topic. Write that one. Special cases of gradient. Special cases of gradient. This is the main topic. The first subtopic. When m equals 0. When m equals 0. Okay. The gradient, if the gradient is 0, then the graph, then our graph is, the shape of graph is, we have to determine the shape of the graph. Okay. Write this again. Write the main topic, special cases of the gradient. Then the first subtopic, when m is equals 0. Now we are going to discuss about when the gradient is 0, what will be our graph? What will be the shape of the graph? Okay. Again, everyone, please look at me and okay, please join to the discussion. Okay. All right. Everyone, please may give me the answers for these questions. Tell me, what is the gradient? What is the gradient? In simple word, you know the gradient is a tan value. No, it is a tan value. Gradient is a tan value. Then tell me the second question. If the gradient is a tan value, look at the arguments. Look at the argument, Puta. Everyone, please look at me. Please listen very carefully about these arguments. First argument, what is a gradient? Gradient is a tan value. It is a tan value. That is simple understanding. Okay. Gradient is a tan value. So if it is a tan value, when m is equal to 0, the tan theta value should also equal to 0. No? When the gradient is equal to 0, that means the tan value should also equal to 0. Then tell me, if a tan value is 0, then what will be the angle between the tangent and the positive side of the x-axis?
180 degree.
180 degree. Others? Do you have any alternative answer? Again, I will repeat that thing. Look at my argument. Please listen to my arguments very carefully. Very carefully, please listen to my arguments. What is a gradient? What is a gradient? It is a tan value. No, it is a tan value of an angle. We have defined that angle. Okay. So, as a basic understanding, it is a tan value. No, M is a tan value. So, if m is equal to 0, if m is equal to 0, then the tan value should be equal to 0 too, no? So, the third argument, that is the third argument. Second argument, my third argument, if a tan value is equal to 0, what will be the value of theta? Go.
The
Sorry?
angle will also be 0.
0. One answer is 0. There's another answer. That is 180. What about others? Ayyo. Only two answers. If a tan value is equal to 0, then what will be the angle? කට්ටියම ක්ලාස් එකේ ඉන්නවා නේද? Very good. Very good. Others? Please give your answers very quickly. Please give your answers very quickly. Then I can understand you are with me or not. Okay. Yeah. The most accurate answer is 0 or 180. Very good, that answer. Because both are correct. Both are correct. Hurry, both are correct. 0 or 180. But the thing is, if it is 0 or if it is 180, the shape is same. The shape is same. Okay. Therefore, there's no difference between 0 and 180. The shape is same. Okay. Okay. Look at the answer. Look at the argument, not the answer. Now we are going to determine the shape when m is 0. When m is 0. So what is the m? M is equal to tan theta, no? M is equal to tan theta. Tan theta means a tan value. Theta means it is the angle between the tangent and the positive side of the x-axis. Okay. That is the definition of theta. So m is equal to tan value. So if m is equal to 0, if m is equal to 0, then tan theta should be 0 too. It should be 0 too. So if tan theta is 0, therefore, if tan theta is 0, then theta is equal to 0 degree. 0 degree, or I can say or 180. But do not consider about 180, because if it is 180 or 0, both the shapes are okay. Both the shapes are equal to each other. Anyway, so if the theta is equal to 180, look at this one. So this is the theta, no, Buddha. Suppose now this is the x-axis. and this is the tangent. This is the x-axis and this is the tangent. Okay. Look at this one. The angle between these two is equal to theta. Is equal to theta. Suppose this angle is 0. If this angle is 0, then this angle should be decreased. No, this angle should be decreased, and the tangent should be parallel to x-axis. No, it should be parallel to x-axis. Look at this. Initially, it has angle theta. So suppose if the angle is 0, if the angle is 0, I have to decrease this one. I have to decrease this one. Decreasing. Then what will happen? If the angle between the x-axis and the tangent is equal to 0, definitely they are parallel. They are parallel to each other. They are parallel to each other. Did you get my point? Everyone, I need your responses. Did you get my point? So if theta is equal to 0, then both x-axis and the graph should be parallel. Not the graph, the tangent. X-axis and the tangent should be parallel to each other. Therium. Everyone. What am I saying?
Yes, sir.
Thank you. Others? Stu, Yanusha? Sudhakar?
Understood, sir.
Okay. Jasmine? Okay. That means we will have this kind of graph. Look at this one. This is y. This is x. Sorry. X, y. So this is theta. So if theta is equal to 0, if theta is equal to 0, that means this tangent should be equal to 0. Therefore, we will have this kind of graph. If this is equal to 0, the tangent and the x-axis should be parallel to each other. Should be parallel to each other. Therefore, this should be parallel. Suppose if there is a graph like this, if there is a graph like this, if there is a graph like this, look at this one. If there is a graph like this, if I draw a tangent at point P, it is parallel to x-axis. Therefore, that the gradient at point P is 0. The gradient at point P is 0. Suppose if we have this kind of graph, look at this one. The tangent at point P, the tangent at point P is parallel to x-axis. Is parallel to x-axis. Therefore, the gradient at point P is equal to 0. The gradient at point P, okay, Pute? The gradient at point P is equal to 0. Otherwise, we can have this kind of graph, no? Those are curve shapes, no? Those are curve shapes. Other than curve shapes, there may be a straight line parallel to x-axis. If there is a straight line parallel to x-axis, m is equal to 0. M is equal to 0. M is equal to 0. Okay. So I can say MP is equal to 0. MP means the gradient at point P, the gradient at point P. MP is equal to 0. MP is equal to 0. Did you get my point? I need responses from everyone. Okay, thank you. Thank you. Yuta. Others? What about our new members? Did you get my point? About these shapes. So if m is equal to 0, the tangent which is drawn at a particular point should be parallel to x-axis. So there may be three types of graph. One is this is a straight line. This is a straight line. If it is a straight line, it should be parallel to x-axis. Otherwise, it may be a maximum or minimum. It should be a maximum or minimum. So at this particular point, the tangent is parallel to the x-axis. Okay. Okay. Try this one. Okay. Try the first topic, special cases of gradient. Then the first subtopic is when m is equal to 0. Then write from here to here, up to here. Draw this graph. Okay, everyone, please write this sentence under this graph. Graph means under this drawing. Gradient is a tan value. Gradient is a tan value. Gradient is a tan value. Therefore, when m is equal to 0, tan theta should be equal to 0. Write in another rule. Write in another rule. That happens only when theta equals 0 or 180. Theta equals 0 or 180. හොඳයි ඊළඟට යටින් ලියන කොටු කරන්න බලාගෙන ලියා ගන්න. So write this one in another paragraph. After writing this one, please highlight that one. Okay. Write this one. Therefore, when the tangent is parallel to x-axis, gradient will be 0. Gradient will be 0. एक कोटू करेगा.
Sir, can you repeat it again?
When the tangent is parallel to x-axis. When the tangent is parallel to x-axis, the gradient will be 0. Okay. Then write the second subtopic, the second case. Gradient increases with x value, m increases with x. Okay. Again. Please listen to me very carefully. Please, everyone, please give your attention. Again, my point. What is a gradient? The first logic. What is a gradient? It is a tan value, no puta. It is a tan value. So, if m is increasing with x, that means when x increases, m increases too. Okay. So, if that happens, tan value should also increase with x value. Okay. Tan value of an angle. No? M is equal to a tan value of an angle. Second point. No? The first argument is Puta, gradient. What is a gradient? Gradient is a tan value. It is a tan value. So if the gradient increases with x, that means the tan value should also increases with x. Okay. Come on. Okay. Shall we draw a gradient? Shall we draw a gradient at point P? Then I should draw a tangent. I should draw a tangent.
So is this coming under the first point or the second?
Madhuri? Sorry?
So should we draw this diagram under the first point?
No. I did not ask anything. Anything right? Okay. Do not write anything. Do not write anything. Still I am describing this one. Liver. Still I am describing this one. Okay. That's why I asked you to listen to me. Listen to me very carefully. Okay. Still I am describing, Buddha. I will give you the note. Still I am describing. Okay. Please listen to me. Please listen to me very carefully. Still I am describing. Okay. දැන් හැමෝම ආයශයක් මාදියා බලාගන්න. Please look at the board again. Please look at the board again. Now I have drawn a tangent, the tangent at point P. So what is a tangent? Again, I am asking what is a tangent? Sorry, what is a gradient? What is a gradient? It is a tangent or tan value of this angle. Tan value of this angle. What is this angle? What is this angle? This angle is in between these two straight line. No? Suppose this one is AB and x-axis. Okay. So theta is the angle between AB and the x-axis. Please listen to me very carefully. Everyone, please listen to me very carefully. I'm repeating this. Please listen to me very carefully. Everyone. Okay. මේක ගොඩක් හොඳ ලොජික් එකක්. මේ ලොජික් එක අපි අන්ඩර්ස්ටෑන්ඩ් කරගන්න ඕනේ පුතේ. ලොජික් එක නැතුව මට words ඕනේ නැහැ. ලොජික් එක අන්ඩර්ස්ටෑන්ඩ් කරගන්න ඕනේ. ඒ නිසා please listen to me very carefully. What is the logic? Look at this. Theta is the angle between AB and the x-axis. AB is a straight line. X-axis also a straight line. Therefore, theta is the angle between two straight lines. Did you get my point? Did you get my point? Theta is an angle. Theta is an angle. Theta is an angle between two straight lines. Did you get my point? Everyone, I'm taggal response then. Yes. So theta is an angle between two straight lines. Is that clear? Yeah. Then tell me. So if the theta is an angle between two straight lines, then what will be its range? Range of theta. The range of theta. What is the range of theta? What is the range of the theta? හැමෝම මට දෙන්න ඕනේ answers. If Again, I am asking this one. Look at this. Theta is the angle between AB and the X. AB means it is a straight line. X-axis also a straight line. Therefore, theta is an angle between two straight lines. Theta is an angle between two straight lines. Therefore, then my second argument, if theta is an angle between two straight lines, then what will be the range of theta? වෙන විදිහකින් කියනවා නම් straight line දෙකක් අතර කෝණේ කොච්චර තියෙන්න ඕනද? 1 to 80. Sorry. Hmm. 180. straight line දෙක අතර කෝණේ කීයද? තියෙන්න පුළුවන් range එක. straight line දෙකක් අතර කෝණේ තියෙන්න පුළුවන් range එක කීයද? It should be from 0 to 180 නේද? 0 to 180. You have done this for geometry. නේ? Yeah, less than 180 or equal to 180. That may also happen. That may නේද? So if theta is an angle between two straight lines, then therefore the range of theta should be 0 to 180. 0 to 180. 0 to 180. Okay? Is that clear? Is that clear for everyone? Please listen to me. Is that clear for everyone?
Yes,
The
sir.
range of theta? The range of theta. Taggal kiyan.
Yes, sir.
Ah. Okay. Therefore, the range of theta should be from 0 to 180. From 0 to 180. Then the tan value of this angle should be tan 0 to tan 180. Tan 0 to tan 180. Therefore, now we should consider the variation of tan from 0 to 180. Then we can understand what will happen to tan value when it change with x. Okay. So the theta lies from 0 to 180. So now I'm going to determine the variation of m. Variation of m means gradient. Gradient means a tan value. So my next logic is, if I want to determine the variation of a gradient, if I want to determine the variation of a gradient, that means you have to determine the variation of a tan value. Okay, that's why I determine the range of the angle. The range of the angle.
So your mic.
Sorry.
We can hear you, sir.
Okay. Again, my arguments. Please බලන්න පුතේ මගේ argument එක. So now I'm going to determine the variation of m with x. Okay. M is a tan value. M is a tan value. Okay. Tan value of this angle. This angle is in between 0 to 180. 0 to 180. So if I want to determine the variation of m, that means I need to determine the variation of tan theta from 0 to 180. 0 to 180. That is my logic. Then We first we will write this logic. Then I should erase this one. Okay. Okay. Write the topic, and draw this graph. Okay, once you finish, once you complete this drawing, please let me know. Once you complete this drawing, please let me know.
Okay, sir.
Okay. Thank you, Buddha. Okay. Right under this one. Gradient is given by a tan value. Right in another paragraph. Consider the above figure. Consider the above figure. Theta is the angle between AB and the x-axis. So theta is an angle between two straight lines. Between two straight lines. Therefore, the range of theta should be from 0 to 180. Write this one. Write this one under the first paragraph. Under the. Write this one in our code, okay? Okay. Right under this. We have to consider the variation of M is gradient, right? Gradient of M, the variation of M with X. Now we know
So we have to consider the variation of M.
with X.
Okay, good.
Now we know that theta is varying, that theta is varying from 0 to 180. From 0 to 180. So the variation of M, the variation of tan. So the variation of tan
Sorry.
so the variation of tan should be considered from 0 to 180. So from 0 degree to 180 degree. Put the degree mark, okay? From 0 degree to 180 degree. Write a new line. Write a new line. For that, For that, the tan curve can be used. The tan curve can be used. Right? Tan curve. Mataga tan curve. Okay. Mataga ini katira. Tan 0 is 0, tan 90 is infinity. Tan 0 is 0, tan 90 is infinity. Then so if it is more than 90, that means if it is an obtuse angle, definitely tan value will be a minus value. Tan value will be a minus value. 90 to 0, from 90 to 180. From 90 to 180, tan value will be a minus value. But around 90, it will be around infinity value, minus infinity value. Then tan 180 is equal to 0. Okay. Actually, we have discussed this graph. Okay. Now we have to utilize that knowledge. So this is the tan curve. This is the tan curve. If you don't know about tan curves, where we can get that one using the values of tan. Tan 0 is 0, Buddha. Tan 0 is 0. Tan 90 is infinity. Tan 90 is infinity. If a tan value is an acute angle, if theta is an acute angle, tan values are positive. If theta is an acute angle, tan values are positive. If it is an obtuse angle, they are negative. Therefore, if the angle is very closer to 90, but if it is higher than 90, tan value goes to minus infinity. Okay. And tan 180 is equal to 100, 180 is equal to 0. So we can draw the tan value up to long range, but we just want the tan value of angles from 0 to 90 and 90 to 180 only. Okay. Look at this again. Okay. Now we know my angle, that means theta is in between 0 to 180. 0 to 180. Therefore, I should consider the variation of a tan value from 0 to 180. According to this graph, there's a cutoff. There's a cutoff at 90. There's a cutoff at 90. It is a discontinuity. At 90, it is a discontinuity. There's a discontinuity of the graph. Therefore, we can consider the acute angle separately and obtuse triangle separately. That is okay. Acute angle separately and obtuse triangle separately. Okay. So first we consider the acute angle, acute region. This is the acute region. If we consider the acute region, you can clearly see when x increases, x not x, theta. When theta increases, tan value also increases. No, look at this one. When theta increases, tan value also increases with theta. When theta increases, tan value increases with theta. Did you get that thing? There another. Did you get that thing? Okay, others? Thank you, Bata. Then tell me. Everyone, I need the answers for this question. I need the answer for this question from everyone, okay? Okay. Then tell me. This is the acute region. If we consider the obtuse region, that means 90 to 180. If we consider obtuse region, tell me what will happen to the tan value when theta increases. When theta increases, what will happen to the tan value? Is it increasing or decreasing? Oh,
Increasing.
others? It is increase. It increases, no? Do not tell negatively. It is very decrease. Look at this. Very closer to 90. If it is very closer to 90, the value is equal to minus infinity. Minus infinity. Minus infinity means very large minus value. Then what will happen? When theta increases, tan value also increases up to 0. 0 is higher than minus infinity. 0 is higher than minus infinity. No. Miriam? Yanusha? Kusha? Okay. Therefore, look at this one. Look at this one. So, in obtuse region, look at this one. Initially, it was minus infinity. If theta increases, tan value also increases up to 0. Therefore, when theta increases, tan value also increases. This is the obtuse region. Obtuse region. Okay. Therefore, if I consider the acute region, so therefore, if we consider the acute region, what will happen, Buddha? When theta increases, tan value also increases. When theta increases, tan value increases. Okay. On the other hand, if we consider the obtuse region, if we consider the obtuse region, if theta increases, tan value also increases. When theta increases, tan value also increases. Tan value also increases. Okay, no? Here. That means now I can come to the logic. Now I can form or create a logic. You know the theta is the angle between two straight lines. Theta is the angle between two straight lines. This is the angle. This is the theta. So the range of theta is in between 0 to 180. Therefore, the range can be divided as an acute range and obtuse range. No, the range of theta can be divided into two portions. One is acute range, other one is obtuse range. We can discuss theta is equal to 90 separately. Okay. Other than 90, I can consider theta in two ranges. One is acute range, other one is obtuse range. So what will happen? Therefore, in both cases, when theta increases, tan theta also increases. Very easy to remember. Very easy to remember. When theta increases, tan value increases. Tan value increases. Okay. And okay. Then we can write down the logic. Before writing anything, please draw this one after this. Okay. Then write down under this thing. Okay, put a star mark and write. When theta is an acute angle, tan theta increases, tan theta increases, tan theta increases. With increasing the value of theta, with increasing the value of theta, with increasing the value of theta. Okay. Within the brackets, from 0 to infinity, this symbol. This is the symbol of infinity. Infinity. From 0 to infinity. Close the bracket. Infinity. Okay. Then next star mark. When theta is an obtuse angle, when theta is an obtuse angle, tan theta increases, with increasing the value of theta, with increasing the value of theta. Okay. Ultimately, therefore, whether the theta is an acute angle or an obtuse angle, therefore, whether the theta is an acute angle or an obtuse angle. Tan theta increases, tan theta increases when the value of theta increases. When the value of theta increases. The value of theta increases. Then you have to write this one and highlight. When theta increases, that means tan theta increases. Okay, look at the board. Everyone, please look at the board. Everyone, I need your attention. Now I can go to the next argument. Next argument means now I can compare this scenario or this result with our definition of gradient. What is a gradient? Now we know the gradient is equal. The gradient is equal to the tan value, tan theta. Tan theta. According to this argument of tan value or variation of tan value, I know when theta increases, tan theta increases. When theta increases, tan theta increases. Tan theta means tan theta equal to m, no? Therefore, when theta increases, m also increases. So, when theta increases, tan theta increases. I know tan theta means m. It is equal to m. Therefore, but tan theta is equal to m. Tan theta is equal to m. Therefore, when theta increases, the gradient also increases. Gradient also increases. When theta increases, the gradient also increases. Okay. Therefore, when theta increases, the gradient also increases. Logic. Did you get my point? Everyone, I need your responses. Everyone, I need your responses.
Yes, sir.
Thank you. Others, did you get my point? Thank you. What about newcomers? Did you get my points? Is this clear with you? Newcomers. Do it. Okay. All right. Okay, right under this, right under this. Okay, right under that. Now we can utilize the above relationship about relationship of tan theta to determine the variation of gradient. To determine the variation of gradient.
So to determine.
To determine the variation of gradient.
Okay, sir.
Okay, write this thing from here to here. Okay. Okay. Now we can determine these shapes. Okay. Shall we do? This is X. This is Y. Still I am X. Okay. This axis is X. The right hand is up here. Okay. Still I am referring X and Y with X and Y because still I am not nominate X and Y axes. So because this is valid for any graph, therefore this is a general relationship for any graph. Okay. Hi. Shall we draw some shapes? Look at this. Suppose take this kind of shape. Look at this one. Now we know when theta increases, tan theta increases. When theta increases, tan theta increases. And we know other thing, point to point, the angle. So the point to point, the gradient can be varied. No? From point to point, the gradient can be varied. That is my first non-thing. The other thing is, when theta increases, tan theta also increases. So I can take 2 points. This is A and this is B on this graph. Then I can determine the variation of theta according to X. Look at this one. Now I'm going to determine the variation of theta. The variation of theta means whether it is increasing or decreasing. Now I'm going to determine whether the theta is increasing or not. If it is increasing, tan theta increasing, no? Therefore, I can determine the variation of M. Okay. Look at this again. Everyone, please listen to me. Everyone, please listen to me. Now I am going to determine the variation of gradient theta. So I have marked 2 points on the graph. Okay. Now I am going to determine the variation of the angle. Variation of the angle theta from A to B. From A to B. Why I am doing like this? Whether this angle, that means theta, whether the theta increases, that means tan theta also increases. Tan theta increases means the gradient increases. Okay. If theta decreases, that means tan theta also decreases. So the gradient also decreases. So that is my argument. Look at this one. Now I'm going to draw a gradient, draw tangent. This is A. So if I draw a tangent to A, you can clearly see now this is the theta. This angle is theta. If I draw tangent to B, suppose this one theta 1, this is theta 2. This is theta 2. Tell me, what is the highest angle? Theta 1 or theta 2? Theta 1 or theta 2? One or two? Theta 2. Yes, theta 2. It is very clear. Theta 2 is higher than theta 1. Theta 2 is higher than theta 1. Therefore, if I take this kind of shape, you can clearly see from A to B, theta is increasing. Theta is increasing from A to B. From A to B, theta is increasing. That means tan theta should be increased. No? You can clearly see theta 1 is lesser than theta 2. Theta 2 is higher than theta 1. That means tan theta 1 should be lesser than tan theta 2. That means tan theta 2 should be higher than tan theta 1. Because theta 2 is higher than tan theta 1. As theta 2 is higher value, tan theta should be higher value than tan theta 1. That means tan theta 1 means gradient at point A. Tan theta 2 means gradient at point B. Look at that argument. Look at that argument. The tan theta 1 means the gradient at point A. Tan theta 2 means the gradient at point B. Therefore, gradient at point A, gradient at point B. That means the gradient at point B is higher than gradient at point B, point A. That means from A to B, the gradient also increases. The gradient also increases. So if we have this kind of shape, normally we call it as concave shape. Concave shape. If we have this kind of concave shape, the gradient increases with x. The gradient increases with x. Did you get my point? Everyone, I need your responses. I need your responses. Others? Come over. What kind of question have you hand? Thank you. You get the other graph. I'll tell below. So if we want to determine the variation of M or variation of gradient, the first thing you have to do, take 2 points. Take 2 points on the graph. Draw the tangents. Draw the tangents and measure the angles. Measure the angle means determine the variation of angle. Determine the variation of angle. If it is increasing or decreasing. If it is increasing, that means tan theta also increases. Tan theta means gradient over the. So if the angle increases, tan theta increases, that means gradient also increases. That is the point. That is the argument. Okay. So do the same thing. Mark 2 points. This is A. This one is B. So A to B. From A to B, x value increases. No, from A to B, x value increases. So what is the angle of A? This is theta 1. This is theta 1. Angle of B. This is theta 2. Angle of B, theta 2. So what is the highest angle? Theta 2 or theta 1? Theta 2 or theta 1? 2. Yes, very good. Theta 2. Theta 2. Okay. So theta 2 is the highest angle. Angle very. Angle very. Theta 2 is the angle very. But the pain is angle very good. Therefore, I can find the same argument. Theta 1. Theta 2 is greater than theta 1. Therefore, tan theta 1 is lesser than tan theta 2. Tan value means it is a gradient. Tan theta 1 means the gradient at point A. Tan theta 2 means the gradient at point B. The gradient at point B. Therefore, gradient at point A is lesser than gradient at point B. Therefore, when x increases, m also increases. M value of A, so m value of B is higher than m value of A. Therefore, when x increases, m also increases. M also increases. The same thing here. When S increases, M increases. So if you have this kind of graph, that means this kind of shapes. If you have this kind of shapes, that means when X increases, M also increases. Normally we call these shapes as a concave shape. This is a concave shape. Okay. Did you get my point? So if it is a concave shape, when X increases, M also increases. But look at the argument. How did you find that term? You have to take 2 points on the graph. You have to take 2 points on the graph, draw the tangents to that points, and determine whether theta value increases or not. Whether theta value increases or not. If it is increases with X, that means tan value increases. Tan value means gradient, so gradient also increases. Okay. Is that clear? Is that clear? Only one, two others. Is that clear? Everyone, I need your responses. Have it. Okay. Then draw this graph. Draw the graph only. No, sorry. Right up to this one. Right up to this one.
Fine.
And what about others?
One second. One second.
Okay. So write under this one, then we can stop the class. Write under this one. If we need to determine the variation of M. If we need to determine the variation of M with X, Then we have to mark 2 points. Then we have to mark 2 points on the curve. Then draw the tangents. Draw the tangents last sentence, no? If we, I will repeat that from the beginning. If we need to determine, if we need to determine the variation, of the gradient, then we have to draw. So then we have to consider 2 points. Then we have to consider 2 points on the graph. Then we have to consider 2 points on the graph. Then we have to draw the tangents. At these points. Then check the variation of theta. Then check the variation of theta. Write in another paragraph. If theta increases, that means tan theta increases. Tan theta increases. Thus, the gradient also increases. Thus, the gradient also increases. In another paragraph,
So the last sentence you said was if x increases, theta increases, and also the gradient increases, right?
sorry, tell me again.
So the last sentence you said was if x increases, theta also increases, and then the gradient also increases. No?
No.
The last sentence you said
Last sentence was
after then check the variation of theta and then
if no, I said
Yes.
if
if
theta increases, then tan theta increases. So, if theta increases, that means tan theta increases. No, tan theta increases. Thus, the gradient also increases. In next paragraph, when theta decreases, that means tan theta decreases. So the gradient also decreases. So the gradient also decreases. Have a look. Stereo.
yes sir.
Okay, with it. So I will give you a small exercise. Okay. This is a homework. So you have to take a rough sheet and do this exercise. Okay. Don't do it in your book. Okay. Don't do it in your book. Take a rough sheet, then do this exercise. What's the exercise? Now we have discussed about the variation, how to determine the variation of theta, then the tan theta, then the gradient. So previously we have discussed there are basically 8 shapes. 8 shapes if you consider two quadrants. 2 quadrants means first quadrant and fourth quadrant. If you consider both first quadrant and fourth quadrant, there will be 16 number of cases. Okay, 16 number of cases. So you have to skip this shape. Okay, this shape, 90-degree shape. You have to skip this shape. Regardless of the shape, you have to evaluate each and every shapes. Each and every shapes means I will put marks. Okay. This one. This is A. B. C. D. E. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. A, B, C, D, E, F. Okay, there are six bundles. There are 6 bundles. First one is A, bundle A. In bundle A, there are 1, 2, 3, 3 shapes. In bundle B, there's only one shape. In bundle C, 1, 2, 3 shapes. Bundle D, there are 3 shapes. Bundle E, there's only one shape. In bundle F, there are 3 shapes. 1, 2, 3. Okay. I need to know the variation of M in each cases. Variation of M in each cases with X. Variation of M with X in each cases. Okay. Take a rough sheet and do that thing and send that to me. Okay. This is an exercise. Okay. So please do it before Sunday. Sunday means you have to submit it before tomorrow evening. And you have to you can take a screenshot here. Screenshot take a So now we can complete today's class with that. If you have any questions, please let me know. Then Sunday we are going to do phosphoric equilibrium. You can submit that on Sunday before Monday, because we are going to do the next class of linear motion on Monday. Therefore, before Monday, you can submit this answer. Okay. Okay. So everyone, if you have any questions, please let me know. Otherwise, we can complete this class. Okay. No comments. Continue the matter. Okay. So good night, Uta. Bye, Bond.
Bye, boss. Good night. God bless you.
God bless you, Uta. Okay. Welcome, Uta. Welcome.